Hi everyone, let's start today's daily eco challenge question. So the question is 2706 buy 2 chocolates. I also have not seen the question before, so let's do it together. Let's read the question now. You are given an integer array prices representing the prices of various chocolates in a store. You are also given a single integer money which represents your initial amount of money. Okay, so I have prices and money, right? And so it means that prices of various chocolates in a store. It means that this chocolate is rupees one. I mean $1 in store one, $2 in store two, and $2 in store three. And I am given three money, and I must exactly buy two chocolates in such a way that you still have some non-negative leftover money. So I should still have no money, and it can be zero because zero is non-negative. You would like to minimize the sum of the prices of the two chocolates you buy. Okay, I need to buy two chocolates. It means that I need to buy two chocolates from different store, and I need to minimize the sum of the prices of the two chocolates I buy. Sum of the prices of the two chocolates. Okay, return the amount of money you will have the leftover after buying the two chocolates. If there is no way for you to buy two chocolates without ending up in debt, return money. Okay, note that the leftover must be non-negative. So it means that here I can buy two and one, right? And so leftover will be two. And what about this one? Here I cannot buy two chocolates, right? Because three, because I mean this money will be spent on buying just one chocolate. If I buy two, then it will be spent. And $1, there is no any chocolate of $1, so I should return three. Nice. And prices dot length. So the length of this price, it can go from 2 to 50. Okay, it means that there will at least be two stores. And prices I, various chocolates in a store. Okay, prices 3 to 3, money is equal to 3. And prices I, it can go up from 1 to 100, and money can go from 1 to 100. Okay, so let me create another example. So suppose money is 3, and suppose if I just want to create a situation where I could have bought, suppose if I had 1, 2, 3, then I could buy, right? Because 1 and 2, it sums up to 3. And suppose if I had 3 and it starts from 1, so yeah, it should be 1 and 1, 1 or something like that. It means that sum of any two numbers in an array should be less than or equal to 3, less than or equal to money. But how will I know if sum of any two numbers in an array is less than or equal to money or not? So suppose in this case I know that 1 and 2, it is 3, right? But if it was 2, then it could not have been possible. I think this is really easy question actually, because I just want to eat a sum of any two numbers would be less than or equal to money, right? So why can I not do this? 1 to 2, right? And then if it is 1 to 2, then I can just search for I can just search for 3 minus so suppose if money is 3, money is equal to 3, then I can just say that when I'm at this point, then I can just say that okay, this is 1, right? So it means that any point, any other number should be, it is 1, right? So 0 at this position, the remaining value I need it's 2, and at this position the remaining value I need is 1, and at this position also the remaining price I will have is 1, right? So what I'm trying to come here is it should be less than or equal to money. I mean, when I'm at point 0, then I know that 2 is required, right? So I can just see here and then check if any number is less than 2 or not. If any number is less than 2, then that is the answer. Basically what I need is actually because I need to return the value, right? I need to return the leftover money. I think I need smallest 2 numbers. So if I have the smallest 2 numbers in an array, then I can just use that value, right? I mean, if the smallest 2 numbers sum, if it is less than or equal to money, then that is fine. I'll return money minus smallest 2 numbers value. Otherwise if even the smallest 2 numbers in an array is greater than money, then it means that I will not be able to buy anything, isn't it? So that is the actually answer. I need smallest 2 numbers in an array. So if you see here 3 to 3 and money, right? Here if you see, then smallest 2 numbers is 3 and 2. 3 and 2 is 5, and it is greater than money, right? So even the smallest 2 numbers could not sum up to money, so I'll just return money. It means that I'll never be able to buy chocolates. Suppose if it was 5, then 3 plus 2 5, it means that I will be able to buy chocolates. So I would return 0 in this case. So yeah, just find the smallest 2 numbers. The value will be 101, I can say, I guess, because it will only go on to until 100. So if price is less than smallest, then if it is less than smallest, then I will say that smallest will be price, right? But if it is not less than smallest, but if it is less than second smallest, then I will have to update second smallest, right? So in this way I will have second smallest and smallest. Now smallest plus second smallest will give me the cheapest price to buy two chocolates. Okay, so this is the cheapest price to buy two chocolates from that store. It means that if this is if money is less than this one, okay, if it is less than this one, then I will just return money. Actually what I can do is return, if money is less than this one, then just return money. If it is not less than this one, then I should return this minus this, right? Because if I have sufficient money, if it is not less than, if I have more money, I mean if I have less money than the cheapest, then the price needed, then I will just return money. Otherwise I will just return money minus whatever I have remaining. Okay, actually this was so easy question, but why did I not come up with this solution quickly? I was thinking about so many things like remaining. Let's look at the editorial. Approach 1 is check every pair of chocolate, and approach 2 is greedy, and approach 3 is counting short, and approach 4 is 2 passes, and approach 5 is 1 pass. Oh my god, what kind of solution did I do? It is so simple. My solution is so simple. Like, why is everything so complex here? My solution is O of n, time complexity, and space complexity is O of 1. Okay, so this is basically my solution. Okay everyone, thank you so much for watching. I will see you tomorrow. Bye.